So again, let's look at another example in which we're given 2 points, 0, 0, and the point 8, -2. Again, if we're given 2 points, our job is to find the slope. So always find the slope first. So again, if I want to find the slope between these 2 points, I'm going to go this -2 minus 0 over 8 minus 0. So we'll get equals -2 minus 0 is -2. 8 minus 0 is 8. Always simplify your slope values fractional wise. You don't want to leave unsimplified fractions out there. So -2, -8 can reduce by 2, so -1/4 is our slope. And if you take a look at this right here, 0, 0, this point here, this x value is equal to 0, which means this is the y-intercept. This line happens to go through the origin. That's what that means. So I'm going to use this point straight away. I don't have to solve for the b value because I know the b value is 0. That's the y-intercept. So I can say straight away y is equal to the slope, -1/4 x plus 0. Or just straight away y equals -1/4 x is plenty. There's the equation of the line in mx plus b form. And we're done with that particular problem. Before we move on to the others, I think you get the hang of how to solve for b. What I want to show you is we have been working with the y equals mx plus b form of a line called slope intercept form. And it's great, you know, you can plug in m, you gotta find slope, and then you gotta solve to find b and build the equation of a line. There's another form of a line we use, and it is called point slope form. A lot of different forms of lines and the way you can present lines. Point slope forms is y minus y1 equals m paren x minus x1. Point slope form. This you must know. You got to know what the slope is of the line, and you've got to know any point x1, y1. Any point. Over here, you have to know slope. Of course, you always need to know slope of a line, but you needed the y-intercept specifically. You couldn't pick any point to plug in. You got to know the y-intercept, the b value, where it crosses the y-axis. If you're lucky enough to have some 0, b value as one of the points given, then that's your intercept. If you're not so lucky, for example, in the problems we looked at before, like this problem here, we were given 2 points. Neither of the 2 points were the y-intercept, so we have to do some algebra to solve for it. The nice thing about point slope form equation of a line is that, let's look at that last example where we had 9, -2 and the point 3, 4. We calculated the slope to be -1. The nice thing about point slope form of a line is that you can use any point that's given to you as your x1 or y1 to plug in, and that becomes the equation of your line. So we got the slope. You got to calculate slope all the time for lines, but if you want to build the equation of the line, let's say I choose this point here. Again, if I'm picking points to work with, I always pick the one that doesn't have a negative sign. So in point slope form, after I find the slope equal to -1, I can plug in into this form of the line by saying, well, y minus, y1 is 4 in this problem because I'm going to use this point here, equals -1, x minus x1 is 3, and this is the equation of the line in point slope form. It's perfectly acceptable to leave it in that form if it's asking you for point slope form, or if it doesn't say a specific form at all. It says just build the equation, boom, you're done. But let's say, for the sake of example, you want to get this into slope intercept form, that mx plus b form. You can easily do that with a little algebra. So I'm going to distribute the -1, so I'm going to keep the y minus 4 on this side, equals, when I distribute the -1 to the stuff in the parentheses, it gives me -1 times x is -x, -1 times -3 is +3, and the next step is to get y by itself, so it gets in that y equals mx plus b form that we're so accustomed to seeing. And if I add 4 to both sides, that will happen. That cancels, so y by itself equals -x. 3 plus 4 is 7. And if you recall from a moment ago, that is the equation of the line we got here using this algebraic technique of substituting in to solve for the b value. Here, we were able to get that same form of a line by using point slope form and then a little algebra to make it happen. And there's your equation of a line. So once again, let's go ahead and practice another example of that in which we utilize the point slope form of a line. Let me find a new clean whiteboard to work with. Erase this real quickly. All right. So again, we're asked to find the equation of a line, let's say through 3, -1, and 2, -3. And we're going to use a point slope first, and then we'll do some algebra to get into mx plus b form, so that if you had to graph it, mx plus b form is a heck of a lot easier way to graph than the other way. So here we go. Our first job always, if we're not given the slope, is to find the slope. I can't mention that enough, how important slope is to linear equations. You've got to be able to calculate slope. So the slope is -3 minus a -1. It's trash truck day. Hopefully it doesn't get too loud. And then we're going to have that over 2 minus 3. So here we go with the slope. -3 subtract a -1 becomes -3 plus 1. 2 minus 3 is -1. And then this becomes -2 over -1, which is equal to 2. So there's our slope. Point slope form of a line says I find the slope, and I can use any of the 2 points. Now, since both the points have negative numbers in them, it really doesn't matter now. I would prefer to pick the numbers that are a little smaller to deal with, so I'm going to go with 2, 3. You could pick either one. It doesn't really matter as long as you pick one of the 2 to work with. And in point slope form of the line, remember it says y minus y1 is equal to m x minus x1. This is our point slope form of the line. And then we can just plug in a value. So we're going to say y minus, well, minus a -3 is y1. And notice how I write it out with the minus -3. Just write the form out. You can simplify the negative numbers later on. Equals the slope was 2, parentheses, x minus x1 is 2. And then we're going to simplify. This side is y minus a -3 is y plus 3 equals distribute these. Gives us 2x minus 4. One more thing here is right at this point, that is an acceptable form of a line. It's in point slope form. You just clean this up, make it y plus 3, but you could stop there. But again, for this exercise, we're going to practice getting it into mx plus b form. So with a little distribution, we're going to subtract 3 from both sides. So this is y is equal to 2x, and then -4 minus 3 gives us -7. There's the equation of the line in mx plus b form. And again, the reason we do that is that we want to be able to sketch the graph of this quickly. So a good review of how we graph a line. If we have to graph y is equal to 2x minus 7, we can graph it quickly on our xy grid. Let's switch grids here. As a review, we're going to go down to -7. That's where you start in the graph. So here's -5, 6, 7. Put a little dot right there. And then we go 2 over 1 is the slope. it's 2, but really remember every whole number is over 1. So it means to go up 2 over 1, up 2 over 1. You can also go down 2, backwards 1, so negative 2, negative 1 makes it positive still. And then we connect the dots, and it gives us the graph of the line relatively quickly. So there's a sketch of the graph of the line 2x minus 7. That is the reason we need to be able to work between point slope form into y equals mx plus b form so that we can graph the line relatively quickly in algebra. Okay.